Hi everyone, in this video we're going to be looking at absolute value quadratic functions, which are going to share some similarities with our linear stuff. But without further ado, let's dive right in. So just like before, let's take a beat here and see if we can conceptualize what's going to happen when we take our basic quadratic graph and we throw some absolute value signs around it. So here we've got y is equal to x squared minus 4. Nice and easy to factor so we know where our x-intercepts are. There's just a vertical translation so we can quickly find our vertex. So how is this going to, or how are the absolute value signs going to transform it? And hopefully you guys can see, just like before, because there's absolute value signs around everything, what that means is that this y needs to be positive. So we can look to our original graph and realize that all these y's that are negative, well, they're going to get flipped back up. And so it's basically just going to be like before where there's a reflection. This one's a little bit easier to draw because I could just take, hey, this -4 would output to be a +4. And I'm just going to use that as an anchor. And we're going to have something like this. Actually, I should have drawn it over here, but all this would go away in an absolute value situation, and we'd end up with this sort of quadratic that bounces. And so basically, when you have an absolute value quadratic, this is what, at the end of the day, what it's going to look like. It's going to look like a W shape, obviously opening upwards if it's got a positive in front of the absolute value sign. If it had a negative in front of the absolute value sign, then it would look something like this, where it would it would bounce down and then bounce up and then bounce down again. So that's if there was a negative in front. But essentially, yeah, that's really it. Basically, there's a few different ways to go about graphing these, and it kind of depends on how the information is presented. So because we're talking about quadratics, you could get that parabola given to you in any of these forms: the standard form, the vertex form, or factored form. And really the quickest way to draw something in absolute values is just sort of draw your basic parabola and then realize that anything underneath gets reflected back up, and then just, quickly reflect it back up. And I would just take a pencil or take an eraser and erase all this. Or you can even make this a dotted line and make this a solid line just to show that you understand that, hey, this is the part that got reflected. But yeah, so when you're looking at features, you're going to find the x-intercepts if they exist. So this is one of those cases where they don't have to exist. And a quirk of quadratics and absolute values is if you have a quadratic that looks like this and you throw absolute value signs around it, it doesn't change it at all because all of your y values are already positive. So you might have no x-intercepts and the absolute value signs might not even change any of the features. But again, it's highly dependent on the quadratic. So you can have basically 0 x-intercepts, 2 x-intercepts, or 4 of them if you've got a situation where it's been translated. So let's say you have like a minus, q value here, whatever it is. And so you've had a vertical translation down, and so your quadratic looks like this. And so you can see you got an x-intercept, an x-intercept, an x-intercept, and an x-intercept. That's the way you can get 4 of them. There's always going to be a y-intercept. You're going to have several vertices. This should say 1 to 3 of them, not 0. I'll change that in your notes. 1 to 3 of them. And your domain and range, like before, it's going to be restricted by the vertices. The domain is always real. And of course, there's still going to be an axis symmetry actually where the original vertex was. So let's do some examples. All right, here we got y is equal to x squared minus x minus 6. So what I'm going to do is, for me, I think it's easiest just to factor this. And so I'm going to write this as x minus 3, x plus 2. And that helps orient me to see, okay, what did this originally look like? So if it's x minus 3, x plus 2, that means I've got an x-intercept at -2 and at +3. And I know my original y-intercept was -6. So I'll put it right here. So I'm going to have something that looks like this just to help me get a visual cue. This is what the original parabola looks like. However, all this gets reflected up because just the entire thing is absolute valued. So instead of this being a -6, it's actually going to be a +6 then. And then whatever this, I think my vertex would be approximately there. We can find it later if they ask for it. But it's going to look something like this. And I'll take an eraser and I'll erase all this junk down here. And that's what my graph looks like there. So let's go through and just fill in the information. So domain X is real, nice and easy. My range is going to be Y is greater than 0. Y is real because I can have any and all values greater than 0 or equal to 0. My axis of symmetry will be whatever halfway. So 3, what is that, -3? So no, it was +3. So 3 plus a -2 divided by 2. I'm just looking for where my middle of the function is. So that's going to give me 1/2. So my axis of symmetry is X is equal to 1/2. Direction of opening. This is actually not the greatest question. It is upwards. We can say that. But I probably will change this for quizzes and stuff. I'm not a big fan of this question in the context of absolute value stuff. The y-intercept is still 0, well, I shouldn't say still, it's been changed. It's 0,6 now. Our x-intercepts are already stated there, 3, 0, and -2, 0. And our vertex, so we've got a few vertices here. This is going to just be referring to our like normal vertex, like this part right here. These are vertices as well. They're specifically x-intercepts too. But I'll just pull this one out to here. So this is going to be 1/2, comma, and in order to get what that y value is, you can just plug it in. I believe it's going to be 6.25. If I do, I'll do a quick check here. So we'll do 1/2 minus 3 times 1/2 plus 2, and then absolute value all that. So what does that give me? That's going to give me 2.5 times 2.5. Which gives me 6.25. Huzzah! Look at that. All right, let's do another one. So here we've got y is equal to -x² minus 9. So again, it helps me to factor this, and I can see that, all right, I'm going to have x-intercepts at plus minus 3. And because of this negative here, I know that my my absolute value quadratic will look like this. It's been reflected downwards. So really quickly, I'll tack on, or I'll put the plus and minus 3 here. Instead of my vertex being at, actually no, my vertex isn't going to change here because of that reflection down. So it is been translated down -9. And normally the graph, so this is interesting, normally the graph looks like this. But we've absolute valued it. So now, and I'll just erase this, I'll show all the steps of how the translations and how the transformations all work together. So because it was reflected up and now or because of the absolute values, it looks like this. Selected the thin one, not the thick one. But then because of this negative in front, everything gets reflected downwards. So now it looks more like this. And this would be the final iteration of our absolute value quadratic. And so this is what the drawing is. Let's state all our features. So 3, 0, -3, 0, and then the y-intercept is going to be 0, -9. Domain X is real. Range Y is less than or equal to 0. Y is real. Axis of symmetry, X is equal to 0 because that's where we can just cut it all in two. Direction of opening is downwards. And the vertex will be -9. And that's that vertex right there. All right. And again, these are also vertices right here. But we've already stated them. So let's go through here. Here we've got x² plus 5. Okay, so this is going to be one of those interesting cases because x² plus 5 is just a vertex, or just a problem that looks like this. Because one, I can see that it's just had a horizontal or a vertical translation up, and it hasn't been shifted to the left or right. So my parabola just looks something like this. So when I absolute value sign it, it doesn't change anything because the all my y values were already positive. So this is an example where the absolute value signs did nothing. And just for fun, we'll go through the practice of sketching just with our vertical stretch. So my vertical stretch is just 1 here. So I'm going to go over 1, up 1, over 2, up 4. So I got to be careful here. So I'm at 5, so 4 to 9 would put me right there. And then I'll do the complementary stuff on the other side. I got to be careful here. Careful, Savoy. This looks like something like this. So what I'm doing there, just as a reminder, is like my core relationship is x to x squared when I'm talking about a parabola. So if I go over 3, I go up 9. If I go over 10, I go up 100. That's how I was getting other points there. And then if there were, oh, geez, I didn't mean to do that. Let's try that again. And then if there was some other like stretch there, then I would just multiply those vertical translations. But so let's just go through this. So this is 0, 5. There's none. My y-intercept is 0, 5 because the y-intercept and the vertex are one and the same. Domain, x is real. Range, y is greater than or equal to 5. Y is real. X equals 0 for my axis of symmetry because that's where I can cut it evenly in two. And the direction of opening is clearly up. Let's go through another one. All right, so here's one in vertex form that's been reflected upwards or changed somehow. So I'll just draw the original graph as is and take a look and see what it looks like. So it's 4, 3. So I'm going to go over 4 and up 3 to right here. And I can see it's going to be reflected downwards. And the vertical stretch is 2. So I'm going to go over x and I'm going to go down 2x squared. So I'm going to go over 2, and normally I would go down 4, but instead I'm going to go down 8. So I'm already at 3, so if I go down 8, that's going to take me to -5 right there. Go over 2, down to 8 right here. And I'm just going to connect them like this. Something like this is what I end up with. It's very steep because of that 2 and because of my scale. But the absolute value signs change things. So it basically means that all my y's need to be positive. So all of a sudden, all this stuff down here gets reflected upwards. So whatever that x-intercept is, I'm going to have to find that soon. Whatever these x-intercepts are, they are going to be reflected upwards. The parabola is going to be reflected, bounce at that point, and I'm just going to erase all this junk. So we get something that looks roughly like that, and that's very rough. But let's find some of our features now. So if I do want to find what my x-intercepts are, I just make y equal to 0. So I'd say 0 is equal to -2x minus 4 squared plus 3. Minus 3 from both sides, divide by -2 gives me x minus 4 all squared. So I've got the square root of 1.5. I'll just do it as 3 over 2. Plus or minus, because I'm going to square root now. Or when I square root, I have plus or minus x minus 4. So it's 4 plus minus the square root of 3 over 2 is equal to x. And I'm just going to write that in right here. So 4 plus square root 3 over 2, comma 0, and 4 minus root 3 over 2, square root 3 over 2, comma 0. My y-intercept. So to get my y-intercept, I'm just going to make x equal to 0. Let's see if I can mental math my way through that. So that's going to be 0, so 16, 32, -32. -32 plus 3 gives me 29. -29, so it's going to be positive 29 in this case. X is real. My range is going to be y is greater than 0. Y is real. Axis of symmetry, x is equal to, where's the middle of my graph? 4. So x is equal to 4. And the direction of opening now, is upwards. Again, I think I'm going to just eliminate this from your quizzes and stuff. I'm not a fan of this feature when we're talking about like quadratics and stuff with absolute values. And of course, my vertex is 4, 3. Do I have another one here? Nope. So that's going to be it for this video. Please come find me in class if you're having trouble. And if not, I'll see you in the next video.